today we're going to discuss the second half of 10.3 with a new concept. But first, let's review what we've done so far. We did some addition with our logarithms, and we did division. Remember, the addition and multiplication are tied together. So that's tied with addition. And with division, it's tied with subtraction. So let's do a couple review problems of what you did on your homework before. Let's say that you were given the fact that the log of base 12 of 3 equals 0.4421, and the log of base 12 of 7 is equal to 0.7831. And then they asked you, find the log of base 12 of 21. Well, you're looking for what you can multiply together to get 21, and you know 3 and 7 is equal to 21. So this can be written as the log of base 12 of 3 plus the log of base 12 of 7, because 7 times 3 equals 21. Well, the log of base 12 of 3 is 0.4421. The log of base 12 of 7 is 0.7831. So when I add those two things together, I get 1.2252, and that would be my answer for that. All right, let's do another one of those. Let's do a division one. Still with the same given, but this time what I'm trying to find is the value of that. Okay, so I've got to look at it and I've got to go, okay, well, I might have to break these into a couple different parts because 12 times 3 is equal to 36. So I'm going to look at it as 36 is equal to the log of base 12 of 12 plus the log of base 12 of 3. Now, 12 times 3 equals 36, so that gives me the top part. Then I'm going to divide it by the log base 12 of 49, so that's a subtraction, because remember division is associated with subtraction. And I've got 49 is equal to 7 times 7, so I can write that as the log of base 12 of 7 plus the log of base 12 of 7. So not only have I done multiplication on this, but I've also done division. So 12 times 3 is equal to 36, 7 times 7 is equal to 49, but it's division, so I have subtraction between them. So the log of base 12 of 12, remember, is 1. So I can look at that as a 1. This is equal to 0.4421. So I'm going to add those together. This down here is equal to 2 of those. So it's 0.7831 plus 0.7831. I have to do the parenthesis first before I can do the subtraction. So I'm actually going to get a value of this right here. I'm going to run out of space down here where you can see it. So I'm just going to give you the answer as 0.1241. Okay, and that's the answer that I'm going to get. All right, so that's just review. That's what your homework for the last video was on. And so now we're going to look at some new stuff, and we're going to look at equations with it, but first we're going to look at powers and what we do with powers with logarithms. So the format for powers with logarithms looks like this. Give that a variable. If I have a power on that number, I can bring the power to the front and multiply it by the logarithm. Okay, so let's do one that involves this. This also is an equation form, and so obviously I'm going to be solving. So 2 times the log of base 3 of 6 minus 1/4 the log of base 3 of 16 is equal to the log of base 3 of x. All right, so there's a lot going on in this problem. Don't get frustrated. It gets easier as you do it. I've got these powers in front. These numbers in front can be brought to the number on the logarithm. So the log of base 3 of 6 can be written as the log of base 3 of 6 squared. This 1/4 can be put on that. So minus the log of base 3 of 16 to the 1/4 power. Don't worry about what it's equal to yet. Okay, so I rewrite it with taking the number in front and putting it as an exponent on the number. 6 squared is 36, so I've got the log of base 3 of 36 is equal to, not equal to, but minus the log of base 3, and then I'm taking the 4th root. Remember what that means? That's like the 4th root of 16, which if you did it on your calculator, you're going to find it's equal to 2. Is equal to the log of base 3 of x. Now notice I haven't done anything to that over there. Now this is subtraction, so it's the same thing as division. So I can rewrite this as the log of base 3 of 36 divided by 2. This divided by this is equal to the log of base 3 of x. Well, notice I'm down to a log of base 3 and a log of base 3. I'm not adding anything to it. Those are just the simple terms. So I find out, and of course that's equal to 18. That's what x is. It takes some work on these. They're just real different than what you're used to. All right, let's do another one. All right, I've got to consolidate these because I can't do anything with them as long as I have the 2 logs on the same side. So I think this one this should be a 10 right here. I know addition is the same as multiplication, so I can rewrite this as z times z plus 3 equals 1. Now, you know I'm going to do distributive property, so I have a z sub 10, or a z base 10, of z squared plus 3z equals 1. Well, I can't cancel out the logarithm because I don't have a logarithm on that side. So I have to write this in exponential form. 10 to the first power is equal to z squared plus 3z. Now I'm going to bring the 10 over. So I have z squared plus 3z minus 10. I'm going to factor z plus 5, z minus 2. So z is equal to negative 5 and z is equal to 2. But then I have to check and make sure that they would work in here. Okay, on this particular one, I'm saying a log of base 10 of negative 5. Well, I'm going, what can I raise the 10 to give me a negative 5? And remember, there's no exponent that would take a positive number and make it into a negative number. So I know that does not work. Okay, normally, just depending on the equation, a lot of times the negative number does not work, but you have to plug it back in to see. If the equation, the variable is squared, then the negative's not going to make a difference. Now your 2 is going to work as you plug it into this problem. So your answer is just simply 2. All right, let's do a few more, okay, because these are weird and different. And I give you examples to look back on while you're doing your homework. All right, notice here I have a 4 in front. So remember that's going to be brought as an exponent there. So I have a log of base 8 of x to the 4th is equal to a log of base 8 of 81. I'm down to a logarithm on both sides. So I don't have a log plus a log on one side or a log minus a log. So Once I get it down to there's just a log on each side and the logs match up, I can cancel those logs out. It's like dividing by the log of 8. So I'm left with x to the 4th is equal to 81. Well, I want to break 81 down into a base and a power, and that's the same thing as 3 to the 4th power. So you can look at this and realize that x would have to equal 3. That and that would have to match up because their exponents match up. All right, let's do another one. All right, this is addition over here on this side, so what I know is that's the same as multiplication. So I'm going to rewrite this with one logarithm, and I'm going to take my y minus 12 and my y plus 12, and that's going to equal 2. Well, I've got to multiply that out. These are conjugates of each other, so it's just Florida. So I get that. Now I've only got one logarithm left, no logarithm there, so I'm going to write it in exponential form. 5 to the 2nd power is equal to y squared minus 144. 5 squared is 25. So what I can do, if you want, is you can add the 144 to the other side, so I get 169 is equal to y squared. When I take the square root of both sides, I find out that y is equal to plus or minus 13. Well, let's make sure that the minus 13 works. If I put a negative 13 there, then I'm going 5 to something power is going to give me a negative 26. Well, again, by an exponent, I cannot change a positive number into a negative number. So I find out that the negative doesn't work. So I'm left with y is equal to 13. All right, now I'm going to give you one to try. Actually, I'll give you a couple of them to try, and then I'll give you your homework. All right, try this one. All right, pause the video and then come back to it and see how I worked it out. All right, these two are subtraction, so I know that this is a division problem. So I write it with one logarithm, so it's 4 over x plus 3 is equal to the log of base 2 of 8. I'm down to a logarithm on both sides, so it's like I divide by the log of base 2, so they're gone. So I have 4 over x plus 3 equals 8. I'm going to multiply both sides by x plus 3. And I get 4 is equal to, and of course I have to do distributive here, 8x plus 24. I'm going to add a negative 24 there, and I get a negative 20 is equal to 8x. I'm going to divide through by 8. And it's going to give me x is equal to negative 5 over 2, or negative 2.5. And that negative works because when I put it up here where the x is, negative 2.5 plus 3 is equal to positive 1/2. So I'm still not trying to take a positive number and change it into a negative number. So that answer works. All right, let's do one more. Again, you work it out and then come back to the video. All right, work it out, then come back. All right, the 1/4 and the 1/3 are in front of the log, so it can be put on the back of the number as an exponent. So I have the log of base 3 of 16 to the 1/4 power, which is the same thing as the 4th root of 16, plus the log of base 3 of 64 to the 1/3 power. So this side I'm still not doing anything to. The 4th root of 16 is equal to 2. So I have the log of base 3 of 2 plus the log of base 3 of the 3rd root of 64 is 4. You can do that part on your calculator. 64 raised to the 1/3 power. Now addition is the same as multiplication, so I have the log of base 3 of y is equal to the log of base 3 of 2 times 4. This times this. So the log of base 3 of y is equal to the log of base 3 of 8. Divide through by the log of base 3, so it's equal to y is equal to 8. All right, and of course that works with no issues. So your homework is page 615, 17 through 37,